I mean, like, there's also what's it called? So there are companies that make just AR glasses that are probably smaller than the Bose glasses, right? So it's them. But what they do is instead of projecting stuff onto the glass, right? Because if it's projected onto the glass, then someone looking from the outside could see what you're looking at, right?
That's what that guy.
But if they look really hard, they can see what you're looking at. So what this one does is it has a very specific reflective material on one of the glasses, right? And it projects it onto that, but because of the reflective material, it comes back into your iris so that no one can see it. And it's perfectly safe. There's no stress to your eyes. It just kind of looks like a palm print. So it just looks like it's boundary view and it's kind of all the stuff you would be reading. Because it's this laser, he looks up just very slightly, he goes if you look directly straight, you can see it. Yes? Oh yeah, yes? Yes. Exactly. I've tried it. They're crazy expensive. They're awesome. I do not have the money to get some myself. I'm okay with just getting very quick. I'm like 650.
Yeah, I don't have that much cash.
Exactly. 150 though? So for these headphones, right? It's like they call them headphones, right? But there's something in your ear. It vibrates your skull, and then it makes noise in your ear. It sounds great. It's perfectly safe and
Next thing you know, everybody can scramble, right?
yeah, exactly. I have tried it. It's really cool. It's really weird. I try a lot of weird, like technical stuff, like not really random,
And you have the test of theory.
You get an extra test.
Just for you. Yeah, I have a whole bunch of them. Yeah. I usually think good. Yeah.
Maybe you were absent. Maybe you were late. Maybe you left early.
Oh, yeah.
Maybe that area just didn't time.
I doubt that third one is
Maybe we all just actually.
I thought it did it. I said, obviously, you told me. Yeah, it wouldn't let you, it wouldn't come up. Yeah. And then, I said, let me just try it. They didn't tell me the time. I went to Google, that worked. Yeah. That was so cheap.
Okay, so welcome.
Bonjour.
Bonjour.
Let's just talk, review about all the things that we know. So, you have a function. You take the first derivative. What does the first derivative tell you?
Critical.
You can find the critical numbers. If you set the first derivative equal to 0, you can find the critical number. The first derivative is actually the slope of the tangent line, so you can find out what happens for those critical numbers, and what are we expecting to happen. Maybe it could be a relative min or a relative max, or not. That's kind of what we're looking for, right? And then we can take a second derivative, because what does that tell us? The IPs, which are called the inflection points, or POIs, points of inflection, either way, depending on how you talk about it. If you set the second derivative equal to 0 and solve, that gives you those inflection points. What is inflection points? What does that mean to you?
When they're changing from,
Yeah, where it changes direction, where the concavity changes. It's going down and then it's starting to go up again. It doesn't happen immediately. You need some time for it to then curve up. Where it curves down and then it's going to curve up again, that would be a relative min, right? That happens. But as it's coming from a max to a min, it's not a straight line, right, from one to the other. There's some kind of curve to it, and it's where the curve changes concavity. Concave up is if the second derivative is positive at that point. Concave down is if the second derivative is negative at that point. So if it is concave up, do we have a max or a min? We have a min. If it is concave down, we have a
max.
max. So you can avoid, maybe I shouldn't say that. You can avoid the sign diagrams, kind of, if you just take the second derivative and look at the concavity of the critical numbers. That would tell you whether it's, you know, a prospective max or min. Now, we also talked about what if we're looking at a function that's over a specific interval. We have the numbers that are the endpoints, right? The ends of the interval. Those also have to be evaluated in the function because those might be the absolute max or the absolute min. So what do we have to do? The endpoints, the inflection points, the critical numbers, they all have to be plugged into the original function to find the values. So we'll talk more about that. So that's what this slide was all about, the absolute extreme values. And then we went on to say, okay, so we're going to take all of these skills. So now you could almost lay them out on the table like, okay, I have this skill, I know how to take a first derivative, I know how to take a second derivative. Now you have to know which tool to pick up to find out what you need. When you go to the dentist, you know how they unroll that whole thing? There's all those tools in there.
And you're like, which one is going to hurt the most?
Yes. Do you want them? Oh, you know, you want them to use the.
Are they going to use the saw or are they going to use the corkscrew thing?
Oh my gosh. Okay, so here were some examples. It says find the absolute extreme value. We did this one together.
Oh yeah, we had to get rid of the 5.
Yeah, we threw out the 5 because
It's trash.
it is not in our interval. We don't allow it to play because it's not between 0 and 3.
Exactly, trash.
Extra. And then we look at the endpoints. So here's that. And that's what we saw. We did those examples. Second derivative test was to say, hey, if it is greater than 0, that means it is concave down, therefore second derivative test. If the second derivative is greater, it means that f has a relative minimum at, going up, x equals c, or second derivative is less than 0, it has a relative max. Okay, then we talked about optimization, yes? What are we doing? We're maximizing things. So if we're maximizing things, we are going to use our calculus. At the end of class, there were a couple people that said to me, hey, we talked about this in accounting, managerial accounting, economics, where a bunch of people in the class are like, yeah, whatever, but the people in here that are doing the calculus and taking the derivatives, when the economics teacher says, hey, we can maximize this by taking the first derivative, usually they don't go through the process of taking the first derivative because they're not teaching you the math. But you all sit in class and go, you know what they're talking about. Okay, so here we did this timber forest example together. So I'm clicking through. we talked about all the different functions, right? You wrote this down in your notes. Little p of x is the price. Little q of x is the quantity. Big P is profit. Big R is revenue. And big C is cost. So those are the different things that we're looking at. So here it says, first, profit is equal to revenue minus cost. Revenue is equal to the unit price times the quantity. And then this gets very not so fun. So here is the price function. P of x. So P of x gives the price at which consumers will buy exactly X units of the product. The price function relating price and quantity may be linear or curved to show to the right, but is always thought to be a decreasing function, right? As price goes down, what happens to quantity? Typically goes up, right? So that is that decreasing function, because it is an inverse relationship. Okay, so let's look at this example. It says it costs the American Automobile Company $8,000 to produce each automobile, and fixed costs, rent, and other expenses that do not depend on the amount of production are $20,000 a week. The company's price function, so here's the price function. P of x is equal to 22,000 minus 70x, where P is the price at which exactly X cars will be sold.
Right.
Are you there? So it says, how many cars should be produced each week to maximize the profit? Well, what's the price of the car? The company's price, so we have this, so let's write that down. P of x equals 22 minus 30x. And fixed costs, rent, and other expenses that do not depend on the amount of production are $20,000 a week. The company's price function is this, where P is the price at which exactly X cars will be sold. So how many cars should be produced each week to maximize profit? For what price should they be sold? And what is the company's maximum profit? So we have to first look at revenue. What did we say revenue is?
Unit price, well, unit cost times
Uh-huh.
unit price times
Which means, okay. Oh, So $8,000 to produce each car, and fixed cost. And the company's price function is P of x is equal to P is the price at which exactly ours. So here we go. Revenue is price times the quantity. So if the price function is 22,000 minus 70p, what's the quantity? How many are we selling? We don't know. That's our. So let x equal the number of cars, right? Such that shouldn't the revenue be equal to 22,000 minus 70x? times x. P of x was given, so replacing the P with the price, and then x is just however many, we don't know, whatever it's gonna be. So, what is R of x? Yeah, 22,000 x minus 70 x squared. And if that's the revenue, and what are we supposed to be finding? Fixed cost. But quantity to maximize profits, right?
The fundamental parts is something we can apply actual that, multiplying the revenues, 20 times.
Profits.
Profit.
We're looking for, we wanna maximize profit. So this is our revenue, but what is profit?
The money you actually
Revenue
made.
minus cost.
Which is 20,000.
So
Times 8x, 8,000x.
we have to put this information into a formula for us. So we were given the price to produce the car, or the price of the car. And then we found the revenue by saying let x equal the number of cars, so there's our revenue. But we need a cost function. So this information, we can say that our costs are equal to, we've got that $20,000 that's a fixed cost,
Yeah,
plus how much does it cost to produce the car?
8,000.
We need $8,000 worth of materials for every car that we're making. So that's our cost. And we said profit, so what we're really looking for is we're looking for a profit function. The profit is equal to the revenue. So we found the revenue to be this. So we're gonna write it in as 22,000 x minus 70 x squared. We're subtracting